Good evening, everyone, and welcome to another Technolive, our fun little live stream here on Tuesdays. And I'm Jack, as always, and as always, that's two as always, two for the price of one. As always, I am joined by my wonderful co-host Dan. Say hello, Dan.
Good afternoon, everybody. I hope everybody is keeping well. And can I just say, Jack, I feel like it's currently unavoidable that we don't start this live stream without talking about the weather because
Oh,
it is
here comes the weather.
beautiful today. But it is beautiful today.
It is genuinely beautiful. I'm sat here at my desk, sun streaming through the curtains. It's absolutely lovely. And even though it's beautiful outside, I hope people are staying safe, staying sensible, and not going out to the beaches.
Absolutely.
In other news, I believe it is Happy St. David's Day for yesterday, everyone.
Yes. Yeah. Happy St. David's Day.
And you might have to correct me if I'm wrong, Dan, but Happus Day Sant?
Yeah, close. I guess you could say that, or you could say Dies Gwyl Ddewi Hapus.
Yeah, that one. I do apologise to Wales for not having the language.
But yeah, do not Dewi Sant. Dies Gwyl Ddewi. Yep.
No. One day we need to do one of these live streams entirely in Welsh.
Absolutely.
Yeah. Anyway, without further ado, let us get started here with, as always, a little bit of our admin. Now remember, you can always visit us at our resources website where we host all of our past live streams. You can find that at bit.ly/technoclubs. And on that website, you'll see we've got a little bit of an announcement on the website at the moment. For those of you who were part of last term's Technoclub Monday, you can now download the Minecraft world that we use there. So you get to explore the houses you built and play around in Technotown.
Fantastic.
Another thing. Remember that on the on the resources website, you can always click the Watch Live link up at the top, and that will take you to a interactive viewer of the live stream where you can send us messages. You can send us little alerts, they speed up, slow down, anything like that. And that way you can get in touch without having to log into YouTube. And just remember, that's bit.ly/technoclubs. That brings us over to what we're doing today, which is a little bit of Python speech synthesis. So Dan, you've done lots of projects over the years, just for fun or maybe for work. Have you ever done anything with speech synthesis?
I have not. I have not done anything with speech synthesis, actually.
No. It's
No.
one of those areas that's a little bit ignored, but it's really up and coming at the moment because, of course, everyone's using Alexa and Siri and whatever Google Assistant's name is.
I think isn't it just Google?
I think so. I know for certain that no one is using Bixby.
No.
There's no love for Bixby out there whatsoever. But short of that, we're not going to make our own virtual assistant today because I did that ages ago. In fact, you would be able to find that trawling back through our old back catalogue of all of our old live streams, going back to almost 12 years. 12 years? Lockdown's not been that long. Almost 12 months now.
12 it has months. Almost been 12 months since we started our Techno Club and Technocamps live streams, which is fantastic.
Yeah. So there's over a year's worth of, weekly videos. Even more than weekly, actually. Anyway, I'm blathering on. The website we are using today is create.withcode.uk. And I think it wins the award for one of the most creative website names, in my opinion. Maybe I'm sad. But this is a lovely little Python interpreter. So it runs Python.
Yes.
But the important thing about this one is it runs a flavour of Python called MicroPython. And MicroPython includes speech synthesis. And we can access that just by going import. Oh, I typed and nothing appeared. What's going on? There we are. In the top line, in line number 1, we can go import speech. And with that line in place, that's all we need to get this computer talking, or screaming, or singing, or whatever. So, can you think of a nice sentence for our computer to say to kick us off, Stan?
Well, given that most of us would start with "Hello World," maybe that would be a nice little tiny good string to start us off with.
Of course, Hello World being the classic programmer's first program. So let's give that a go. So, to get the computer saying something, we need to say speech, because that's the library we are accessing. The speech library is basically a list of code that we can call on different parts of. And we're going to call on the say part of it. So I've written out the name of the library, which is speech, which we imported on the first line. And after typing speech, I'm going to put immediately afterwards a full stop. And then I'm going to say what piece of code do I want to take from that library. And I want to use say. So speech.say. And say has an open bracket after it. And basically, anything that goes after this bracket needs to be a string. So, how would you describe a string?
A string is, I guess you would say that it's anything that goes between quotation marks, really, isn't it? So you could have anything inside of a string. You could put letters, whole words. You could put even put numbers inside of a string if you wanted to.
Yeah, it's kind of a way for the computer to represent text.
Yeah.
So, as Dan said, it needs to be in speech marks. So I've got the opening speech marks, then what I want to say, then the closing speech marks. I also need to close the bracket.
Yeah.
But it's any kind of text. So you could have the entirety of the hungry caterpillar as a string if you wanted to. But not the images, only the text part. That's a really bad example. Does it have much? I haven't read The Hungry Caterpillar in goodness knows how many years. Does it have much? I can't remember. Does it have much text?
There's some text. But I think it's mainly about the fun pictures.
Yeah. I don't know. This stream's already off to a bad start because I've gotten nostalgic about Hungry Caterpillar. It's all I can think of now. But anyway, speech.say hello world. And before I continue, I need to make sure that I've opened a rounded bracket and I've closed a rounded bracket. And I've opened the speech marks and I've closed the speech marks. But speech.say hello world. Let's click play and fingers crossed this works and isn't too loud. It's a pretty nasty voice, but we'll be able to play around with that. So let's play.
Hello world.
I believe that came through. It might have been a little bit quiet.
I'm just seeing how it came through my end.
Yeah, I won't turn it up too much because you can have a go on your own computers at home. You don't necessarily need to listen to mine. But
Hello world.
Oh, it came through not too loud.
Yeah. A nice great big green play button, and it'll say "Hello World" in your ear. If it doesn't work, all I can suggest is trying another browser. I'm doing this in Firefox, and it works fine. I think it works quite well in Chrome, but it might.
I'm using Chrome.
Yeah, it might be a bit unhappy in some browsers like Safari or other ones.
Oh, yes.
So yeah, basically, we've got it saying "Hello World," which is pretty good. We can make it say something longer. So, hello, I am a scary computer voice. I have no body. Maybe it's a ghost, a computer ghost.
Hello, I am a scary computer voice. I have no body.
There we are, and it'll say whatever you want it to say. And we could do some fun stuff with that. We can mess around, but we've covered that before on a live stream. Let's spice it up a little bit. So I'm going to just change it back to Hello World. And luckily, we've got options here to add a little bit of interest using something called parameters. So let me have a little look-see. I've got it written down here somewhere.
So there are we can pass parameters into our into various bits of code in order to change the output of our code. So it can have by passing in parameters, we can change what comes out at the other end.
Yeah, parameter is very much like telling the say command to say in a certain way. It's giving it more information about what we want to say.
Yes.
So to start putting in these parameters, I'm going to go put my cursor before the rounded bracket, but after the speech mark. And I'm going to pop a comma in, because we always put parameters in as a list, and we separate each part with a comma. So with that, we can do our first parameter of the day, which is speed. We can change the speed at which this computer is going to say something. And 0 is fast, and the number 255 is slow. So I'm going to type in the next parameter, so speed equals... what do you think? Slow or fast first?
Let's go. I say let's go with fast first. Let's go with fast first.
Okay, I won't do it too fast. I'll do it as 10. So 10's going to be quite fast. Let's see how it sounds.
Let's see. Well, if you caught it.
Yeah, that was pretty fast. Let me play it again. It just bloop.
Yeah.
So let's slow that down a bit. Let's change it to speed equals 20. You can actually make up some words there. Speed equals 30. Yeah, and obviously the larger the number I make there, the slower it's going to go. So let's try for the maximum now. The maximum speed, which is 255. Let's give that a go.
Hello world.
Ooh, that was pretty nasty in my ear, but yeah, that was pretty slow. So we're able to add a parameter, the speed parameter, which has slowed everything down quite a bit. So we've been fiddling around with speed What do you think the next parameter might be, Dan? I'm challenging you. I'm putting you on the spot.
Well,
What usually goes with what usual audio effect is kind of followed on after speed?
I guess we could say something like the pitch, perhaps.
Yeah, so the pitch, which is how low or how high the sound is, and it's different to the speed, which is how slow or how fast. But they're kind of linked, and they're kind of linked because you can't really do it nowadays. What with all this Spotify and YouTube music, but back in my day, you used to be able to play music on cassettes or CD or record much slower than you were meant to. So, back when you're talking about music, speed made things lower as well as slower. But here it's different. Speed is different. Is separate. So we can make things slow without making them low. So
Yes.
now we do want to make things low. So we're going to introduce the next parameter. So it's the next one along, so I need to put a comma after speed equals 255. And I'm going to pop in my next parameter, which is pitch. So it's introducing a new feature of live streams. It's Dan's choice.
Oh.
Pick a number between 0 and 255.
Let's go with 100.
100. Nice. Kind of in the middle. So we're going to type out the word peach. Peach. Not peach. Pitch. We're going to type out the word pitch. We're going to say pitch equals 100. Remember, it's still going very slow. Let's see what slow sounds like with pitch equals 100. Let's click play. Yeah, that's pretty good. If we wanted to make it higher pitched, we can make pitch very small. So let's make it, 28.
Oh dear.
Oh, that's a sound and a half.
That is.
Let's make it a little bit faster, because otherwise we're going to be stuck listening to some very interesting sounds. So I'm going to change the speed to, let's stick a nice 100, because it's kind of middle-ish. It's not exactly in the middle. But yeah, we've made the pitch high pitch. Let's make it low pitch with the maximum at 255. Yeah, that's pretty deep. So yeah, we can play around. We can make it incredibly high pitch. Let's try it at 1. That's interesting. If you do pitch equals 1, that is so high pitched that the that Python's not coping with it, so it kind of defaults to being low pitched again. So sometimes when you make it too low a number, it has the kind of the opposite effect.
It does, yeah.
So let's try 2. Let's see if 2 is still too high.
I would argue that 10 seems to be its limit almost.
Let's try 10, as you say then.
You see what I mean?
I don't know whether you picked that up at home, but oh my word, that was an interesting sound. It sounded like a...
It was just a squeak, really.
I know, it sounded like a... Well, I mean, we've hit the description on the video. This video is titled How to Make a Computer Scream, and that's exactly it.
It does, and interestingly, if you start to go back down through the pitch, so if you start going into 9 and 8, there are certain letters that it struggles with, but others that it will put notes in higher pitch.
Let's give that a go. So I'm going to try it with pitch equals 9.
And you'll hear the squawk, intertwined with random deep words.
That's pretty cool. Oh, wow, okay. So, yeah, you can have lots of fun playing around with that. Let's stick it at 50. Let's see what 50 sounds like.
Hello world.
Yeah, quite high.
Yeah.
25? Oh, that's quite shrill. But yeah, you can have all sorts of fun with that, and you can achieve lots of interesting effects, lots of interesting styles, and there's actually genres of music now that are all about using speech synthesis to make music. And yeah, speaking of which, big news in the music industry. I don't know whether you've been following, Dan, but have you heard of Daft Punk breaking up?
Oh, no, I have not.
No, so Daft Punk, very famous electronic music duo. They wore helmets, never showed their face, and they used speech synthesis in their music all the time, constantly. Like, they had the song Harder, Faster, Better, Stronger.
Oh, of course, yeah.
Which I think I'm going to get this incredibly wrong, but I think Kanye did a cover of. I think we're both clueless on that.
Yeah, I think so.
But yeah, they've done lots of music over the time using speech synthesis, like One More Time, Around the World, and yeah, they've just broken up, sadly.
Oh, right.
Anyway, that's a bit off topic. But using speech synthesis, and you'll be able to play around with the speed and the pitch and all sorts, you can start making interesting sounds and interesting patterns and maybe even music using methods like this. But we've got 2 more parameters to go.
We do.
We've got the next one, which this is where computer science and linguistics kind of cross over. We've got the mouth parameter. And it's a bit hard to describe. It's basically kind of the mouth shape of the imaginary mouth that's saying this voice. So let's just try it and let's see what difference we get. So it's a new parameter. So I've added a comma. And this parameter is the mouth. Let's say mouth equals. Let's try it in the middle-ish with another 100. See what it sounds like. Okay, I'm going to turn the pitch down a little bit because it'll be clearer. So I'm going to make pitch 100 again. So everything's 100, we're kind of resetting things, but let's see what mouth 100 sounds like. Sounds fairly normal. Let's go a bit more extreme. Let's make mouth equal to 10.
Oh, yeah.
That's interesting. It sounded kind of breathy almost in my ear.
Yeah, well, it was, yeah.
It kind of sounded a bit like the imaginary voice was a bit strained. Maybe even a bit constipated.
Oh.
Sorry, Dan. But yeah, let's try it at the other extreme. Mouth equals 255, which is the maximum.
Oh.
That sounds like the voice is kind of coming from, deep in the throat.
Yeah, it was very throaty.
Yeah, so let's try 200. See what we get. That And we get some really interesting stuff. We can try all sorts, and we get some really weird stuff, some really cool stuff. Oh, that one was really deep. Try mouth equals 60.
Let's have a look. Oh, that's an interesting one.
Yeah, it's kind of got layers to it. It's really hard to describe how mouth works. Which brings us on to the last parameter we'll have a look at, which is the throat parameter. So it's a new parameter, so I'm going to put a comma and a space. And the throat, so typing out throat there, we could say throat equals, well, again, it goes from 0 to 255. And throat is all how relaxed or how tense the voice is. So 0 is meant to be really tense, and 255 is meant to be really relaxed. Let's go traditional and go straight down the road with 100. See what that sounds like. Sounds pretty normal. Let's turn that up to 255. That is a weird sound.
That is a really strange sound.
I'm not even going to attempt it in real life, but wow. So that's throat equals 255. We can then bring it down to 10, which apparently should be really tense.
If anything, it's gone much deeper.
Yeah, that's an interesting one. Let's try throat equals 50. It's definitely sounding very alien. You'd make a good alien in a sci-fi film with this.
Yeah.
70? Ooh, 70's weird. But yeah, anyway, there's 4 parameters there. There's speed, pitch, mouth, and throat. And you can give them any numbers from 0 and 255. You get some really crazy effects. So, what are we going to do with that? Well, I've got a little bit of a video lined up. Yeah, so basically, speech synthesis has been around for years. It's been around since even the 1930s. So it's not a brand new thing. And I'm going to show you one of these speech synthesizers from 1939. And we can have a little look at how it works. And see if we can replicate that with modern technology. So let me introduce the Voda.
The machine uses only 2 sounds produced electrically. One of these represents the breath. The other, the vibration of the vocal cords. There are no phonograph records or anything of that sort. Only electrical circuits such as are used in telephone practice. Let's see how you put expression into a sentence. Say, she saw me, with no expression.
She saw me.
Now say it in answer to these questions. Who saw you?
She saw me.
Whom did she see?
She saw me.
Did she see you or hear you?
She saw me.
And there we are. So I'm not sure how much you're able to make out. I had to quickly mute stuff in the background because my phone started going off.
No, it was coming through quite well.
Oh, that's good. I'm glad. But yeah, so this was the Voda. And the way it worked was this wonderful device had a kind of like keyboard on it. And as you played certain keys, it could produce certain sounds. So the reason I bring that up is we could easily get the Python speech module to say anything we want with speech.say, and But that's kind of easy. You know, anything can do that nowadays. And we've already demonstrated that with Hello World. To make it a little bit more interesting, we're going to try and do it the Voda way. Now, the Voda broke the English language up into separate sounds. And these sounds are called phones. And it's basically made of lots of different sounds. So, for example, you've got a, b, s, k, and all those kind of sounds. But you've also got the longer sounds like a, and I, and oo, and so on.
Yes.
And what these very clever people would do is they'd have access to all of these sounds, and they'd be able to make speech just by typing out the right sounds. So we're not going to use speech.say anymore. Instead, we're going to use something that's a little bit more precise called speech.pronounce. So let me type out speech.pronounce. I hope I spelled that right. I can never... Have I?
It's coming through.
Yeah, no, I spelled it right. I'm happy. Now, speech.pronounce is a little bit different. It doesn't work the same way as speech.say. Instead, it takes a special kind of takes its own language. And it's a little bit difficult trying to work out what that language is. So to help us, we're going to get Python to do all the translation for us. So before I do speech.pronounce, I'm going to do something else which will tell us what the kind of language code for Hello World is. So
Right.
to do that, I'm going to print a value to the screen. And the keyword for that is print. And inside print, next to print we have an open bracket and a close bracket, inside which we print what we want to say. So, what do you want to say first? We want to say hello world. We need to work out the language code for it. We're going to use another function of the speech library called translate. So inside the print brackets, I'm going to say speech dot translate. And after the dot translate, there is another open bracket and another close bracket. So I'm going to give you a little bit of time to think now, Dan, of what we are going to... What sentence should we say next? But whilst you're thinking about that, we can talk about what goes inside the translate bracket. So, again, like speech.say, it takes a string. So I type a speech mark, and at the moment we're just going to start with hello world. So I'm going to type in hello world. I'm going to close that with another speech mark. So just to count up, we've got print, we've got open bracket, then speech.translate, then another open bracket, then hello world in speech marks, then close bracket, close bracket. So there are four? Not Thor, as in the chap with the hammer, I mean 4. There are 4 brackets together. And when we click play, it says hello world as normal, but then prints out what the right code is to use the pronounce function. So the
Yeah.
pronounce function uses slash and hello world.
Mm.
So I'm going to copy that. Not the whole line. I just want the... Come on. Ugh, why can't highlighting behave? Let's copy that. And on the next line, now I can do speech.pronounce. So speech.pronounce, open bracket. And again, this takes a string. So open speech mark, paste the language code for hello world, then close speech mark, close bracket. And let's click play and see what it sounds like.
Hello world.
So, first of all, it said hello world with all of our weird parameters. Then it printed out the language code for it to the screen, and then it pronounced it. So yeah, we can use the dot pronounce one as well. And do you have a sentence we can try out with this one, do you think, Dan?
I was thinking of something. Well, I mean, it was quite simple sentence, but we could say something like, "Welcome to my first speech synthesis program."
Fair enough. Let's first translate that. So to translate that, I'm going to replace hello world in the brackets to welcome to my first speech synthesis. Oh, I hate spelling. Welcome to my first speech synthesis program. Okay. And I won't be able to put anything in here until I know the language code for it. So we're just going to leave it as hello world for now.
Hello world.
Okay, so it says hello world. Then it prints the language code, which is a little bit interesting. It's welcome tux may first speech syntheses program. Let's copy that. And let's put it in the... Let's replace the hello world of speech.pronounce with that. Where does it get tux from? I just don't understand.
Before, partway through speech.
Ah, so I'm glad you drew attention to that. I might be wrong, but I think the numbers are all to do with the pitch of certain parts of the word. So maybe the 4 here is saying that the ch sound should be lower than the sp sound. Which kind of makes sense, doesn't it? Because sp sounds kind of high-pitched.
Yeah.
Whereas the ch, it's quite low. So if everything goes to plan, it should say, welcome to my first speech synthesis program in perfect English. Let's give it a go.
Welcome to my first speech synthesis program.
Interesting. So it worked. It was a little odd in the fact that it said program. It had that pause in the middle. But hey, it works. So this is where we can get interesting. And we're going to use the dot pronounce and the dot translate. And we're going to try and sing a song. Now, do you have any preference for song, Stan? I've got as backup Old Lang Syne, but I wonder if you had a better idea at all.
I feel like we're entering the realms that we were in before about the with the music industry, and in the sense that I have no idea.
Exactly. I mean, mine's only from the 1800s.
But I mean, we did do our Burns Night Minecraft
We did,
stream
yeah.
not long ago, so perhaps it is relevant.
It's relevant. So, possibly Old Lang Syne. I was just hoping there's another one out there that's more kind of. I suppose everyone knows Old Lang Syne, so let's give that one a go. For those who don't know the song, I'm not going to sing it because I do not have a singing voice. It's an old Scottish song, and we always sing it at the end of. We always sing it on New Year's Eve, and should old acquaintance be forgot and never brought to mind? Should old acquaintance be forgot for the sake of Old Lang Syne? For Old Lang Syne, my dear, for Old Lang Syne, we'll raise a cup of kindness yet for Old Lang Syne. And basically, it's a lovely little song about saying, we're now moving on to the new year, so goodbye to the old year, goodbye to the old times. So, the first word, which is should. So let's translate should. So I'm just getting the lyrics up here because I will forget them. Where are they? Marvellous. Oh, I've only managed to find them in the original Scottish, which might not be so helpful. But yeah, should old acquaintance be forgot? So again, we're going to use another of our print statements. Actually, we can cheat here a little bit. We can skip the printing out to screen entirely if we wanted to. Instead of printing to the screen, instead of printing the translation and copying the translation, we could actually just do the translation inside the pronounce function. But that is kind of cheating. So, it's up to you. But let's do it word by word. So let's do a print. And rather than printing the translation, we're going to print the first word. Or the first phone, the first sound. Which of should is sh. So, print sh. And remember, it needs to go in the speech marks. And with that in place, I can now do speech dot pronounce, and rather than finding out the translation first, instead I'm just going to do speech again. For this I'm .translate, and then open another bracket, so we're 2 brackets deep now, and we'll do the first sound, which is sh. Close bracket, close bracket. So we print sh, we pronounce the translation of sh. So it should give us something like this.
Welcome to my first speech synthesis program.
And it was very quick, but you heard a sh sound. And we'll be able to go back and slow it down later. But that's exactly what we're going to do. We're going to build up the song syllable by syllable, and then maybe tweak them a little bit. So, question: how would you pronounce the uld? How would you spell the uld sound of the second half of should?
Oh.
I mean, my spelling's atrocious, and I feel guilty for putting you on the spot.
Oh goodness. Could you type? Try typing out how you believe it should be.
Yeah.
And then perhaps and then we can maybe tweak it from there.
Well, I'm thinking maybe it should just be the letters LD. Because if you say them, they kind of got an sound to them.
Yeah, Yeah, let's go with that and see where we.
So I'm going to print to the screen and then do speech dot pronounce speech dot translate open bracket and then just letters LD and see what comes out. It could be fascinating, it could be terrible, but fingers crossed.
Welcome to my first speech synthesis program.
Oh, I don't know whether you heard it, but you could actually hear a should. It was very quick, but it was actually there. It was a should. So I'm going to get rid of what we've got so far because not everything. I'm just going to get rid of where we say hello and welcome to my first speech synthesis program because we're going to be experimenting, playing around with this lot, and it'll take a long time for it to say it every time. But let's click play. Ooh. So it is saying should.
Excellent.
Which means we can move on to our next word, which is old. And I can't think of any way of saying old other than old. So let's just say that. Print old. Let's do it with the pronunciation again. We're using the pronounce this instead of say because it means we can be more precise with tweaking how each syllable sounds. So I know we're translating them automatically into the speech language, but if we need to change a word, we could change the speech language directly ourselves. So speech.pronounce, speech.translate, old. So now it should say should old. That kind of worked, but did you? It's not come through for you yet, Dan. But we heard in our ears that the kind of the middle of the word was too high pitched.
Let's see. Oh, hang on.
It wasn't saying.
Oh, yes, it was.
It wasn't saying old. It was saying old.
It was, yeah.
So this is exactly what I'm saying. We can go in and tweak that word and change it to our heart's content. So the first step to doing that is to work out what the language code for it is. So I'm gonna go upper line and go print speech.translate old. So we're printing what the language code is, the speech language. And as you can see, it's printed it out for us, and it thinks old has a 4 in it. So that 4 is changing the pitch.
Oh, yes, yeah.
So I'm gonna take that language code for the word old, and I'm gonna pop that in the pronounce with speech marks around it. Oh, I'm pressing all the wrong buttons. And maybe we can change this word up by changing the 4 to something like 5. Let's see if changing the 4 in the middle of old makes to a 5 makes it sound different. Okay, it's a little softer. Maybe
Alright.
try an 8. Okay, 8 was a little bit too low because I went old. Let's try 7. That kind of works. Should old. You know, it's kind of more flat now.
I'm just hearing the 8, the old with 8 come through.
Yeah. The only thing I'm thinking is the kind of the W sounds a little bit still too high pitched.
Hmm.
So maybe I'm just experimenting here. It could be completely wrong. I'm gonna put a number in front of the W. I'm gonna try 6. Oh, okay. No, I've got an error. I've got a nasty little error. Okay, so yeah, messing around with the language code of a word can sometimes throw an error, and that's because the language code is quite hard to understand. So if you start adding stuff into it willy-nilly, it might not be so happy with that. But long story short, I think we can now be happier with how it says old. It's not high pitched anymore. It's back down to. I mean, if I change that to a 1, it goes really high pitched. Old, which honestly didn't work. So yeah, we can fiddle around with that to make that sound more realistic. So we've spent. Goodness knows, 20 minutes doing that, and we've got 2 words. 2 words of a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of a 10-verse song.
This could take a while.
It could take a while, but let's just plow ahead straight with the next one. The next word is a little bit of a longer one. Acquaintance.
Ooh.
We should probably break that up a bit. So, the first syllable. It's kind of ack, isn't it?
Yeah.
So let's try the letters A, K together. So ack.
Yeah, that seems reasonable.
Yeah. So I'm just printing that out so we can see it on the screen. Let's do speech.pronounce, open bracket, speech, or translate, ack. And I'm going to get rid of this old printing of the translation of old on the screen because we don't need that anymore.
No.
But yeah, let's try just the letters AK. Oh, okay, I made a mistake. I typed in speed.translate, not speech.translate.
Yeah, just seeing that come through.
It threw me for a second. So yeah, it's saying ack. It's saying ack a little bit high pitched, but you can as we did with old, we can bring that down. Or we could do it a different way. We could put the comma, and then we can use the parameters. So I can use the parameter pitch equals, and we can make it a little bit lower pitch, like 200. So I'm doing this after the speech.translate. I then put a comma, and then I say I set the pitch to something lower. Okay. Still a little bit high pitch. Let's bring that even lower. Okay, it's not doing anything. I don't know whether that's a bug or whether that's me using the pitch parameter in the wrong place. Not sure what's up with that, but you know, these things happen. Let's just skim over that one a little bit. I don't know why the pitch wasn't working there, but might be something to look into later at another time. Sorry, I'm just working out what the next syllable is. The word's acquaintance. I'm thinking the next thing we're going to say is sort of a wane sound, or a quain sound.
Yeah.
Let's print, and Let's try it with the QU, see what that causes. So, Quain. Let's try that. Speech dot pronounce. Speech dot translate. Quain. 2 brackets to end it off with. Let's see what that sounds like. There, that works.
Oh, excellent.
Should old Aquain. And the final one, I think it's going to be a little bit tricky this one because it's a
Yeah.
tans. Yeah, it's not a tans. It's a tans. It's a very it's a very sharp S. Do you have any ideas for how we can spell tans?
I mean, we could just try straight up TANS and just, but then again, it might struggle with the S.
Yeah, I keep thinking that's going to be a tans sound. Are there any other letters in the
What about with a C, perhaps?
That will be tank, but if we put an E,
An E at the end, yeah.
maybe? Fingers crossed. So speech dot pronounce, speech dot translate, and what is hopefully tense. Let's give it a go. Hey, that's perfect.
Excellent.
And it's not too far from the actual spelling of the word.
Perfect.
But, you know, this is nice and easy for us. If you can imagine it back on the Voda, you have to produce the tans sound using the t and s. You know, the three, you know, those combination of sounds together. It sounds quite difficult. There'd probably be a sound for tan or ta. Yeah, there'll be a sound for ta, a sound for n, and a sound for s. And you'd have to put all of those together.
Much more tricky than doing it through Python.
Yeah, we're kind of cheating a little bit, but hey, it works. But, yeah, let's... Oh, we just got 2 words left and 2 minutes to do it, so let's get that countdown clock going. I don't have a countdown clock, but, you know, and I don't think we'd even be able to play it. But,
No.
Just imagine the countdown clock ticking down in your head, and then... So the next word is bee. I'm just gonna spell it like the insect. I'm sure it'd be fine with B with just 1 E, but I'd be worried it'd be too B. You know, it'd be too short.
Yeah, I think it would be.
Because in the song, the B is quite a strong word.
It is.
Speech. Don't translate. B. Let's give it a go. Okay, it was a little short actually, even with the E. So let's make it longer. Let's make it B. Okay, maybe a little bit too long now. So I'm going to shorten it out a little bit. Just to 5 E's. Ignore me, I'm just giving myself some more space at the bottom of the screen. But I think B is sorted. We can try the next one, which is forgot. I wonder. I want to try something. I don't think it's going to work. I want to try it with the number 4.
You know, I was thinking the same thing.
So we're just going to see if the translate function will translate a number into a word. It could work, or it could throw a really nasty error. Now, even though it's a number, the translate function requires a string. So I'm sending it the text of the number 4, rather than sending it the number 4 directly. Because otherwise, it'd throw a wobbly. Yeah, 4 works. It's able to translate numbers.
That's fantastic.
So we got the 4 for got. Let's just do got. So let's give that a go. Oh, okay. Lasty error. I think that was just it's getting tired. I don't think it was a problem with our code.
Okay. Yeah, I'm looking at your code and it looks pretty okay to me.
Tell you what, I think we have there a lovely first line of our song.
Excellent.
And it works quite well. Should old acquaintance be forgot? Yeah, and obviously we can tweak all of these. Remember, if you look along the bottom as it's running, it's actually doing the different codes for the pronouncing along the bottom. Remember, we can tweak any of those however we want. And we can maybe mix in speech.say as well a couple of times rather than speech.pronounce. We could get some really cool songs out of it. And I think we've done all right with
I agree.
With Old Lang Syne. And part of the reason that Old Lang Syne works is, well, the Voda actually sang it during one of its demonstrations in 1939. So,
Oh, interesting.
yeah, if I can dig it up, it will involve me finding it online first. I'll put it in over the end credits, so you'll be able to have a little listen. So at the end of the stream, stick around for 2-3 minutes if I find that. But before we get going and say goodnight for the evening. Good night for the evening? That doesn't make sense. Say good evening for the night. Good. Say goodbye to the stream. Remember that you can view all of our past live streams over at bit.ly/technoclubs, where you can let us know anything about how the stream went, or any questions or anything like that. Remember that we currently have a competition on the go, available at bit.ly/gameofcodes2021, where the challenge is to make a piece of software using anything that you want to, be it Python, be it Scratch, be it MakeCode Arcade, be it anything. Any piece of software that's all to do with the education of the future. And before we close out, the schedule for this week, we are 2 days down. We've just finished Screaming Computers. Dan, I forgot your name then. That's just embarrassing.
Yeah.
Sorry. Dan is doing a little bit of sequencing and decomposition over on the Wednesday Technoclub. And the Friday Technoclub are just doing all sorts of random cool coding projects. So if things like that interest you, remember you can sign up to the Technoclubs available at that link before, bit.ly/technoclubs. In any case, that's it from me, and that's it from my wonderful co-host Dan.
Thank you very much, Jack.
Yeah, and I think that's all we have to say is good night, goodbye, and if I can find it, stick around for 2-3 minutes in case I find the Voda song.
Take care, everybody, and have a good week.
Enjoy your week. Cheerio.
Bye-bye.
Oh. Oh, welcome back, everyone. I found it. So, here to play us out for the evening, here we have the Voda playing Auld Lang Syne.
She called and see for and never going on. She called and see for and
I'm sure that if I sang that song, I wouldn't sound as good as the voter.